Acceleration only happens when there's a net force on an object. This is called Newton's first law of motion, named after Isaac Newton, very famous, very powerful scientist from a few hundred years ago who first figured this out. You can't make a change in speed happen unless there's a net force on the object. Now here's what a net force means. We're going to talk about this a little bit more later on, but a net force means a force that isn't balanced on that object. So if I push hard in this direction on an object, but I push equally hard in this direction on an object, that's not a net force, and there will be no acceleration. If I push on this object very hard and I don't push at all from the other direction, or if I push only very lightly from the other direction, then I've got a net force. It's unbalanced, and so the thing will be accelerated. Another way of saying this is only force causes change in speed. Let's take a look at multiple graphs here and see what happens when we put force on an object. So we're looking at this object here, a ball or something like that, and on this graph we're measuring where is it, what is its displacement. Here we're measuring its velocity or speed. Here we're measuring the acceleration on the object, and here we're measuring the force. So we can get a relationship with the force that causes the acceleration, that causes the change in speed, that causes the thing to change its position. So let's take a look at several steps. First of all, I've applied a force. This arrow, this vector, represents a force pushing on the object. I have no displacement yet. I have no velocity yet. I have no acceleration yet, but I have seen my force jump up. Now, the force has been applied for a little while. Now, the acceleration begins to occur. As soon as I place a force on there, now I have acceleration. The force hasn't changed its size. It's still at the same magnitude here. That means the acceleration is constant. Force and acceleration turn out to be proportional to each other. If force doesn't change, acceleration won't. If I'm accelerating at any acceleration, well, that means that my speed is changing. That's what acceleration means. So I see an increase in my speed. Well, as my speed increased, another thing that happened is the object actually moved. And I saw it physically move here, and I saw a graph of motion. Well, the force is still constant after this unit of time, so the acceleration is still the same change. Acceleration being change in speed, well, I see my speed has gone up. Because my speed has gone up, this unit of time, the last unit of time, saw a bigger change in displacement than the first one did. Next unit, still constant force, which means still constant acceleration, which means still a constant change in speed. But the speed has been going up, which means in this next unit of time, I cover even more distance in my displacement. Same story here. Now the force suddenly drops to zero. When the force drops to nothing, I have no more acceleration. If I don't have acceleration anymore, my velocity isn't changing. My speed is the same. So that means I will now have a constant line that shows what my displacement is as long as there isn't any more change in speed. And that would require a force. Forces cause objects to accelerate, and they accelerate in this way. They accelerate in the direction of the force. So if I have a force that's pushing this way, my acceleration will also be that way. If I'm pushing straight east, I'll accelerate straight east. Now, acceleration doesn't always mean you're going faster. Acceleration may also mean that you're going slower. If the velocity was in the opposite direction of the force, if I'm moving west and I put a force on this way, if this is speed and this is force, I'm going to have an acceleration in this direction, and that'll actually slow things down. Sometimes we call that a deceleration. We also know that forces cause an object to accelerate with a magnitude that's proportional to the force.